Let's talk about Cupid. Thanks for that lovely introduction, gentlemen. I will try to make this make sense. So yes, as Dan was saying, this whole idea started with some critique of Solid, and it was in a place called PubConf, which is it's a kind of fun after party conference from NDC. So NDC, dotnet developer conference, is now much broader than dotnet, but that's kind of its roots in Oslo, and it travels around the world. And I think I was in London. And PubConf is it's a little mini event that happens afterwards. And they take a load of the speakers, and you have these 5-minute lightning talks. So the idea is it's called an Ignite style talk. So you have 20 slides in 5 minutes, and they run 15 seconds per slide, and it just auto advances. Okay. And I thought, well, I'm going to talk about Solid. And the reason I want to talk about Solid is I'm lazy, and so Solid is 5 principles of software. And I figured what I would do is I would spend one 15-second slide describing the principle, another 15-second slide critiquing it, and a third one saying what I'd do instead. And that's 15 slides, and then you top and tail it, and that's 20 slides. So basically the talk wrote itself. So I figured that would be fun. And then as I was writing the talk, I realized that my advice for each of these 5 principles was the same, which is don't overthink things and just try and write simple code and keep things simple. And during the talk, I described what I mean by simple. But anyway, so and it went across well, it was received well. And then I made the crazy mistake of posting my slides online, and lots of people got very cross because they had no context for the talk, and they just saw me on the internet saying something about Solid, which they cherish as a religious totem, and so they came for me with pitchforks. Just very briefly then, Solid is 5 principles of software that Robert Martin put together in the 90s. He actually has loads of these. He's got well over 100 of these. And the first 5, it turns out you can arrange them to spell the acronym SOLID. So you have S is single responsibility principle, which is that code should have one reason to change. O is open and closed principle, which is about when and how you should change source code. L is Liskov substitutability principle, which is about type systems, but OO people think it's about objects and class hierarchies. I is interface segregation, which is when you have a massive bloated interface, you should turn it into smaller interfaces. And D is dependency inversion, which is how you should construct things. And so for each of these, I kind of proposed a critique, and some of them were more pointed than others, if you like, more opinionated than others. And in each case, I was saying, let's just do something different. So this was 2017, I think. So then last year, 2021, beginning of 2021, there's a meetup called the Extreme Tuesday Club, and it's I think I'm right, it's the oldest XP meetup in the world. And it started in 2001 or something. And they've been meeting every week in a pub in London. During the pandemic, of course, they were meeting virtually, and they still meet virtually, or occasionally they have hybrid meetups. And the XTC, the Extreme Tuesday Club, they contacted me and said, look, we're doing a session on Solid. It would be great if you came along. So I said, yeah, sure. I know there's some folks there that I know, and it's a lovely group. So I said, okay, I'll come along and do that. And just before the event, one of the organizers, Phil Nash, he said, okay, so you're not a fan of Solid. What would you replace it with? And then there's kind of like the broader question of, are there universal principles of software? Are there universal things that you would replace that you could describe? Or is it just all a bit nebulous and that doesn't work? And so I did. I came up with an acronym, and it's actually a backronym. So a backronym is where you start with the word, and then you make up the things to fit. And it was February, it was near Valentine's Day. And so I decided I was going to use the word Cupid because it has 5 letters, and because it's like the opposite of, solid, macho. Cupid is like romance and hearts and flowers. And And I figured that the software craftsman bros would really not like a thing where Cupid is the center of it. So now I had to come up with 5 things that were that made the acronym Cupid. So I did this, and it went across really well. I got some really good feedback, really encouraging feedback. And then what happened is, because most of my work I've discovered is based on other people's deadlines, right? So I wouldn't have come up with Cupid, but someone challenged me to. I wouldn't have then started talking about it, except that I agreed to speak at a conference a few weeks later and thought I should talk about this. So Cupid had a very humble, I didn't sit there, mulling on this thing for months and months. It had fairly simple beginnings. But then what happened is it kind of picked up some momentum, and people started talking about it. And I was going to multiple conferences, all virtual conferences during last year, and speaking about Cupid, and it got picked up, and it was really, it's got some crazy momentum. So about a year later, so this is now early 2022, it appears on Hacker News. So it's down here on the front page of Hacker News is my article about Cupid. And really frustratingly, it happens on the 15th of February. So it's one day after Valentine's Day that it appeared on the front page of Hacker News, because that would have just been perfect. But so suddenly people are taking notice. And then I discovered that Cupid is now on the ThoughtWorks radar. So the ThoughtWorks radar, you've probably come across, it's published every, I think, quarter. And they talk about things that you should adopt, which is, they say, this is a good idea, you should do this. Assess, which is, this is a good idea, but it's new, so you should at least take a look at it. Hold, I think, which is their language for stop doing this because it doesn't work. And Cupid appeared as assess. So we think it's a good idea and you should take a look, which was really exciting. And then I looked at my website analytics, and it turned out that so my website kind of flatlines like this, and then it just goes bang, because I'm not very good at publishing content. I do it very infrequently, but it seems to be popular when I do. So I suddenly had, in like a handful of days, I had like 50,000 hits on the website. And as you can see, this is what happens when you appear on Y Combinator on Hacker News, is that 10,000 people hit your website. Twitter was there's a lot of Twitter activity. And then ThoughtWorks, these are all the click-throughs from the ThoughtWorks radar. And so it was quite fun. So I discovered, that my static website, I'm using Hugo now, I've moved away from WordPress, so my static website hosted on GitHub Pages can handle spikes, yes. And also that my my analytics software, Fathom, is very good at handling spiky traffic and telling me about it. So so there we go. So this is like a year, I guess a year and a bit now after I started talking about it. And it seems to be picking up momentum. This is really exciting because I love talking about good software. So what do I mean by good software? Let's set the scene. Let's set the scene by asking who we are writing code for. Now, this is one of my absolute favorite quotes, and I came across this probably late 90s in Martin Fowler's book, Refactoring, which he published in 96. He in the opening, I think, preface maybe, or certainly in the opening chapters, he says this. He says, any fool can write code that a computer can understand. Good programmers write code that humans could understand. And I had this epiphany. It was wonderful. I had this moment where I thought, wow, I'm not hacking words into a computer to make it do stuff. I'm writing code for other people to work with, and other people might be future me, right? So this is about self-care as well. And so in the context of this, I'm looking at this and I thought, well, understand is an interesting word, but it's a pretty low bar. Someone can understand this code if they stare at it for long enough. Can we do better than understand? And then a few years ago, I was at a Kevlin Henney talk, and Kevlin Henney does brilliant talks where he really researches things, and so he has lots of references, and he started talking about habitability of code. And he said habitability, and he used this Dick Gabriel quote. So Richard Gabriel, one of the great software thinkers, he wrote a series of essays, and he published them in a book called Patterns of Software in 1996. 96 apparently was a good year for software writing. So Patterns of Software, a series of essays. Please go and read this. They're all in the public domain. They're all hosted on his website. And this one is called Habitability and Piecemeal Growth. And it's just a beautiful piece of writing. So do yourself a favor, go and read Habitability and Piecemeal Growth, and just take a moment to appreciate that there are people out there who really care about how human beings interact with software. And he says this: habitability is the characteristic of source code that enables, and then he says a whole bunch of different roles, that enables people to understand its construction and intentions and to change it comfortably and confidently. I thought, oh, comfortably and confidently. When's the last time I felt comfortable and confident in someone else's code? He says, habitability makes a place livable like home. And I thought, that's great. So habitable sounds better. And I thought, well, habitable again is kind of, it's you can get by day to day. What about joyful, right? Have you experienced joyful code? So I just want you to take a moment now and ask yourself, have you worked on a code base that is joyful to work with? That just you crack open the code and you smile, you look at it and you say, oh, I'm going to be okay here. Today is going to be a good day, right? You go in, especially into an unfamiliar code base, you've got trepidation, you're nervous, oh no, this is going to be such a nightmare, and you pop it open and, oh wow, this all makes sense. This all just fits in my head. I get this. So what makes it joyful? Can we describe what makes it joyful? And then, in particular, what kinds of properties does joyful code have? I'm being very deliberate with my language here. So solid is based on principles. It's a set of 5 principles out of, as I said, a collection of well over 100 software development principles, design principles. I found that as I was thinking about principles, they didn't really work for me. So I found that I ended up looking at properties. And the reason for that is that principles are kind of rules, right? So they define the conditions or the boundaries for something. So they say what's inside and outside. So your code conforms to the conditions or it is wrong. And you see this a lot, or I see this a lot with particularly young male programmers, fresh out of college, coming into their first or second job. And they look at a code base and they go, oh, this is all wrong. And so what's wrong with that? Oh, this violates the single responsibility principle. This violates the principle of least surprise. This violates the da-da-da. And so they're going around policing the code. And you're just thinking, honestly, there must be better things to do with your time. So your code conforms or it's wrong, right? And those are your options. So properties are more like qualities or characteristics. So they define a center. So the idea is that any code is like nearer to or further from that center, but it's never like wrong, right? So you can say, well, based on these, if we think about what this characteristic of this code expresses this characteristic a lot or not very much, and it gives us a sense of direction as well. It says, if I want to change this code to exhibit more of this property, to be closer to this center, what do I need to do? So I'm going to get a bit meta for the moment. I want to talk about the properties that properties should have, or at least when I was formulating Cupid, what did I want? How did I want to describe each of these properties? And I came up with 3 things that I figured if I were hearing these things for the first time, how I would want someone to describe them to me. So the first thing is I want them to be practical. I don't want abstract things. I don't want deep philosophy. I don't want semiotics. I don't want any crazy. I want things that are easy to articulate. So they're easy for someone to describe to me and they're easy for me to describe to you. Easy to assess. So I can look at some code and say, to what extent does it exhibit this property? How close is it to the center? And also easy to adopt. I didn't want like a hard and fast set of rules that are all or nothing. I want to be able to look at some code, look at these properties and say, right, let's start shifting this piece of code in this direction. And that is a piecemeal, easy, local set of changes. So I don't need to convince everyone to come on this big adventurous journey with me. I can just make small changes to make the code more habitable, more joyful. The second thing is I want them human. What I mean by that is, again, Solid is a great example of this. Solid is principles written from the perspective of code. It's what code should be and what code should have. Whereas these properties are from the perspective of the human beings working with the code. So when you look at code, the extent to which it makes you joyful is a subjective experience, right? So the properties that I want to describe are human. They're about you and about your interaction with code. And the third thing is I like the idea that they're layered. So they're nuanced. So when you're first describing some of these properties to people, they're going to go, okay, that seems familiar, that seems to make sense. But then as you get more experience, as you get deeper into software, as you look at more and more code bases, you work on more code, you gain more experience, you can revisit these properties and see more and more texture to them, more and more nuance to them. So that said, here's Cupid. So I'm going to give you my 5 properties, my 5 characteristics of joyful code, and then I'm going to spend a bit of time unpacking each one. Okay. So composable. I like code that's composable, that plays well with other code. I like code that follows the Unix philosophy of doing one thing well. So it's comprehensive and it's single purpose, it's focused. I like code that does what I think it's going to do. I like code that's predictable. And I'm describing predictable as a generalization of testable. So predictable is code that does what you think it does. Idiomatic. Idiomatic code looks like code everyone else writes. Idiomatic code is egoless code. So I'm not going to write code and have people go, that must have been written by Daniel because that's Daniel's code style. I want to write code where people look at it and say, that was written by someone who is an experienced Kotlin programmer or an experienced C# programmer or an experienced Rust programmer. That they understand the idioms of this language and they are writing idiomatic code. They're not trying to write, and you'll see this in .NET all the time, when people first start using F#, for instance, from C#, they will write C# in F#. They'll try to write, method type things and object type things and class type things in F# while they're getting the hang of thinking functionally. They'll want variables because they're not used yet to the idea of immutable values and transformations. They will want to iterate over things where you might have a map reduce or a recursive function or a closure, because those concepts are new. So you tend to find, I did this when I was learning Python. My background was in Java, and I had Java style classes and objects all over the place. And it turns out that idiomatic Python is much, much more lightweight than that. And what I found over time is I was just deleting most of the code I'd written and just leaving what I needed. And I ended up with much, much less code. And it looked like Python code now, instead of looking like someone trying to write Java in Python. And finally, domain-based. So this is code that uses both the language of the domain and is structured for the problem I'm solving. So let's take a look at each of these in turn then. Composable. So code that's composable, code that's easy to use, gets used and used and used. Okay, so I want code that's easy to pick up, easy to use. What makes code composable? Having a small surface area makes code composable. So if I look at NUnit or JUnit or any of those kind of unit testing things, in order to write a test, I need a test case and a fixture and a test class, and the class has methods on it, and the methods have to have an attribute on them to say that it's a test method, and so on, right? So there's a bunch of stuff I need to do to use this, and that there's a learning curve ahead associated with that. In Python, there's a lovely little test framework called PyTest, and literally the way you write a test is you write a function whose name starts test underscore, and it will run as a test. You don't even have a cert, and you don't have a cert equals, right? Because the word assert, the keyword assert, is baked into the language, And so what PyTest does is you just use the keyword assert with like just double equals or doesn't equal or whatever your comparison is. And if that assert fails, it prints you out this very, very readable error message. It says, this is a line of code. These were the two values. This is why it didn't work. And also, this is where these values were assigned. So you can go straight into the code to where the problem probably is. And once you've used something as lightweight and powerful as PyTest, you look back at the things you've been using all the time and say, wow, I've gotten so used to all this other stuff that I had to drag in. Small surface area, less for me to learn, less for me to get wrong, and also less to conflict. One of my very first open source projects back in 2003, I reckon it was some code that it tests a really horrible enterprise Java thing called enterprise Java bean. If you've never heard of enterprise Java beans, you are living your best life. Okay. So this code tested enterprise Java beans, particularly for a thing called IBM WebSphere, which again, if you've never come across it, thank me. But the idea that there was less to conflict. So I had some logging in there, okay? And the problem with the logging is that I was using a logging library. And that means that if you wanted to use my thing, you had to use the same logging library at the same version. And so now that was a barrier to entry. And so my colleague pointed out that I had this dependency, and I was like, so what? It's just logging. But then I removed that dependency, and suddenly people started using this open source code because they could now. And the reason they hadn't been was because they got stuck. So composable code has an intention revealing name. I can find it, right? There's no point you writing a brilliant, lovely little small surface area library for me to use in C# and putting it out there on NuGet, and I can't find it because you gave it a really clever, fancy name instead of just describing what it does. And there's a lot of fancy names out there. So give me an intention revealing name, make it easy for me to find, and make it easy for me to evaluate. Let it be very easy for me to determine if this isn't what I want. If I can find out within 2 minutes that this is not what I want, you've just saved me a load of time, and I will thank you. And again, we want minimal dependencies, so we don't want it to drag in everything. There's a lovely web framework called HTMX. And HTMX is saying we've massively over-engineered things and overcomplicated things with JavaScript and all these heavy JavaScript frameworks, and your Reacts and Reduxes and Views and Embers and Angulars and all of these things, right? These big, heavy frameworks. Just use HTML. Just use HTML. They made a tiny extension to HTML so that you can have basically you can add behavior to any HTML tag rather than just to forms and buttons, anchors. Really minimal. The entire library is like 12K or something. It's really tiny, and it has 0 dependencies. So guess what? It's really easy for you to pick up and use. There's this wonderful quote from the late Joe Armstrong, who designed the Erlang language. And he's talking about OO here, object-oriented languages here. He said, you wanted a banana, but you got a whole gorilla. I want to use some tiny little bit of behavior in one of the methods on your class. And so in order to get that, I need to pull in your object, its class definition, all the superclass definitions, all the interface definitions. There's this ton of stuff that I get just so I can get this one bit of behavior. He said, and that makes it really hard, or that makes the decision to use your stuff much harder. So there's composable. We want small surface area, intention revealing code, and we want minimal dependencies. So Unix philosophy then. Unix has been around about as long as me, right? We're both in our early 50s. Unix started in at a university. It started in a telco in the late 60s. And then it was adopted by a university, and then it went back out to the telco, and it's been around a bit. And then the Unix you will most likely have come across started as a hobby project by a Finnish programmer who wanted to build his own running kernel on Windows, on MS-DOS, sorry, at the time. And that became Linux. And so Unix has been around a long time. And part of its longevity is it has this very, very simple design philosophy. So in Unix, everything is a file, and files contain text or not text. That's it, right? So when I say everything is a file is a file, a directory is a file, a tape system, if you're putting stuff onto tapes back in the day, is a file, hard drives a file, network devices a file, the memory is a file. Anything, so what that means is I can use file type semantics, basically hierarchies of stuff, and at the leaf nodes they contain things, to describe anything on a running Unix system. And they had this philosophy. They say, make each program do one thing well. And there's two parts to that. There's one thing and there's well. So doing one thing means it's got a single purpose, and doing it well means it's comprehensive. I don't need to look anywhere else. And that, along with composability, is pretty powerful. So let's take a look at the ls command. The ls command lists file details. That's what it does. It's like, I think it's a get object in PowerShell. ls lists files contents. But here's the fun thing. ls doesn't know anything about files. Okay. All it knows about is the output of a command called stat. And stat is the thing that knows about files. So stat goes and looks at files or directories or whatever ls tells it to look at. And it comes back with a bunch of structured records that tell you what those files contain. And ls's command is to format those structured records into something on the screen. So you see how these are very separate things. Stat just returns the structured records, but they're really hard. There's tons and tons of stuff in there, and they're hard for humans to interpret. ls takes that and says, I'm going to give you something that you can read as a human being. So, and ls, if you look at the manual page for ls, ls has a lot of parameters, right? A lot of switches, because there's lots of ways you might want to look at details about files. And so what that means is you don't need to go anywhere else to learn about file content, to learn about your file listings. You just use the ls command. And yeah, so together with composability, then there's really nothing you can't do. So the idea that files are text and then everything is text is you can take this then to composability to say the output of any command should be text, which I can use as the input to any other command. So Unix gave us the pipe operator, which is how we sequence things together. So for instance, cat gives me the contents of a file, and I can pipe that into grep, which is a filter, so that filters things. I can pipe that into sed, which transforms patterns. It finds a pattern and replaces it with something else. I can then sort the results, so now I get an alphabetical output. And then of that alphabetical output, I can use unique, which removes any duplicate rows, and so on and so on. And again, PowerShell sort of adopted this idea, but I think it got it annoyingly badly wrong, in that it tried to use, well, it introduced an object-oriented language into the command line instead of a pipe-oriented language. So basically you can think of all of these as functions. These are all transformational functions. And so if you had a functional type of thing in PowerShell, I think it would be a lot less difficult on the brain. So we have, objects with methods and all this kind of stuff. And there's this huge, huge complexity to PowerShell that you simply don't have to a regular Unix shell that has commands, and the commands by and large use text, and they manipulate text and pass text on to the next thing. So, but surely doing one thing well is the same as single responsibility principle, I hear you say. Not really. So SRP is about how the code changes. The canonical description of SRP is code should have one reason to change. And in my original talk, I was saying that that's completely insane, because any code could have many reasons to change. It could have functional reasons, it could have legal reasons, it could have security reasons, it could have operational reasons, it could have many, many reasons why it might need to change, for any single line of code. So that's a bit of a non-statement to me anyway. But when you unpack it, what they're really saying, which kind of makes sense at the time, again, solid is not a bad idea, it's a bad idea now. In the 90s, it was what we thought about object-oriented programming. So it was good advice for 30 years ago. Okay. And 30 years ago, you would often have different people, often completely different teams, working on the same code. And so what single responsibility said was, please don't have people from different teams hitting the same source files. That's crazy, right? So break it out so that there's only one type of person who's going to go in there and change this code. So if I have a form on a screen, then the UI part of that form, the client part of that form is probably one team. The data access part of that form is another team over here with the DBAs and data access and whatever else. And then there's a bunch of business logic probably involved in this form that some business team would work on. So SRP makes sense in that context. As soon as you have the same team all responsible for all of that, and often the same person, it's completely insane to say code should have one reason to change. Code should be changed by one person or the same people who are going to understand all of that. Great. But you can do all of that in one source file, which we'll come to later. So SRP is about how the code changes, about people changing the code, not what the code does. So it's an inside-out perspective, not an outside-in perspective. Unix philosophy says, don't care. Don't care how it got there. It does one job, and it does that one job comprehensively enough that I don't look anywhere else. Okay, so P, predictability. Let's look at predictability of code. One of my favorite descriptions of predictability is Kent Beck. In amongst his 4 rules of good programming is that it passes all tests, right? It works, yeah? So behaves as expected with no surprises. It passes all tests. I'm kind of broadening that definition. I'm generalizing that definition to say even when there are no tests, okay? So it behaves as expected. What I mean by that, let me give you an example of this. And this is one of the first code bases I ever worked on. This is back in probably 91, I think. And it was image processing software. So digital image processing, which is you take in huge, at that time, huge digital images. And the images are made up of pixels that have 4 color components. So basically four numbers. And the numbers stand for printing ink color. So you have cyan, magenta, yellow, and black, CMYK. And cyan, magenta, yellow, and black are the colors that you use when you are printing color printed newspapers, magazines using massive print rollers. So I was working on software that made it easy to test the image that you were going to print before you printed it, because once you're printing it, it's very expensive to find out you got all the colors wrong. So what we had was basically a 4D color cube. So it was a mapping of these sets of 4 colors. You put this into this cube and it would come back out with the 4 colors transformed. And you did that for every single pixel in the image, and then you now had the color corrected image. Somewhere deep in this morass of very complex image manipulation code or image color manipulation code was a bug. And that bug was assigned to me. Dan, fresh out of college, going to the heart of this really big complicated system written in probably hundreds of thousands of lines of C, maybe millions of lines of C. It was a big program and it was all written in C. And find the bug. And I'm not kidding, I was terrified, right? So I crack open the code base, I'm like, where are we? And I had that joyful moment. I looked at the code and I was thinking, this makes sense. I get this. I can navigate this. And there was a brilliant tool, open source tool around at that time called C-tags. And C-tags was a way of basically being able to click through. Yeah, it's kind of like when you do control click now on source code, and you can go to references and go to definitions and find usages and all of that. This was in VI in the early 90s, and it was pretty groundbreaking stuff. So I could navigate the code through my editor. And very quickly, I got to where I thought the bug probably was. No tests, right? Just in very, very simple, well laid out, well structured code that I could navigate. So I find out where I think this bug is, and it really was one of these logic errors, like a less than instead of a greater than, or a missing equals, or something like that. And so I then fixed the bug. And I was pretty confident that I fixed the bug. I was pretty confident that I hadn't broken anything else. I then rebuilt the code and took, again, no tests, right? No automated tests. We didn't do that then. And I took a big image and I put it through the now fixed code, and it came out looking exactly like the original image, but the bug wasn't there anymore. And I was like, yes. And I can't take credit for that. right? That wasn't me. That was a guy. I'll tell you his name. His name's Phil Davis, and I learned a lot about programming from Phil Davis in the early 90s. I don't know where he is now. I'm sure he's somewhere on LinkedIn, but he had this mindset of, I'm going to write code that other people are going to want to work in. And so it doesn't need tests to behave as expected. Okay. And conversely, some of the worst code I've seen was completely test driven. You know, TDD is a fantastic way of doing design in the small. It leads to very good, clean, local implementation. It doesn't have an opinion about design in the large. You can't TDD your way to good architecture. You can't TDD your way to a good cohesive overall system. You have to have that in your head. Your team has to have decided what the big picture architecture is going to be, and then you TDD the parts. So I've worked in teams where very experienced TDD people didn't do that, and so the code was completely hard to navigate, but had tests all over. So even when there are no tests, deterministic, predictable code does the same thing every time. Okay, even if it's something like a random number generator or something that has non-deterministic behavior, it's programmatically non-deterministic. It's predictably non-deterministic. So, and it has well understood operating characteristics. I can look at this code, and I can see that it uses this much memory, it uses this much CPU, it tends to run for this long, requests take about this much time to come back. And so I can now make predictions based on that, and I can make assumptions based on that. And I can start, once I have predictable pieces compose better. And you start to see that these properties now all interplay with each other. So composable and Unix-like, doing one thing well, and predictable suddenly gives me pieces that I can put together into much more complex systems whose characteristics, whose behavior I have much more of a handle on. And it's observable, and observable in the Mipsy-Tipsy Charity Majors observability sense, in the technical sense of control theory, which is that I can infer internal state entirely from outputs. So I can look at what something's doing, and it tells me how it's going inside. And for most software, that's not true. And for most software, if you don't design this in from the get-go, adding it later is generally painful. So I bake in instrumentation, I bake in telemetry as part of my design, as part of my core coding habits, if you like. And once I have something that behaves as expected, is deterministic in its runtime characteristics, and is observable, so it tells me when something surprising is going on, or when something surprising is going on, I can very easily determine why, what the likely cause is, then that code is much more predictable. Idiomatic then. So idiomatic code, there's a couple of parts to this. The first part is that it uses the language idioms. So that means that I use standard language features and constructs. I use standard libraries. I use standard, where there are multiple tools and frameworks, I go and find out what the ones are that people use. So that code feels natural and goes with the grain, right? So you have, I've often done this. Like, as I said, when I was learning Python from Java, I was trying to use Java style tooling and Java style whatever, and it turns out Python's a much lighter, simpler language than Java or C#, because it's dynamically typed. That you can fall into a lot of traps that a compiler will help you with in statically typed languages. But by and large, you write less code. So understanding the idioms of the language you're working in. I remember I spent some time learning Clojure, and Clojure is a modern Lisp designed to run on the JVM. So it has good interoperability with Java, but it's basically a Lisp. It's parentheses and some other stuff. And I'd never really learned Lisp. So I found that I was writing very imperative kind of procedural style code in Clojure, or reinventing a bunch of things that were in the core library. And my programming experience with Clojure was write a bunch of code, discover something in the standard library that makes it go away, and then something else, and then something else, and end up with like the 3 lines of code I should have written in the first place. So an awful lot of my short-lived Clojure programming career was deleting things I'd written. But again, this is how you learn the idioms, is you make all the mistakes and you try things out. As well as like the core idioms that you'll find in the language, your organization, your team, your code base, your product will have its own house style, right? There'll be coding or design standards. They may well not be written, right? They may not exist in any formal way. So they may just be de facto what's already there. And one of my favorite quotes about consistency comes from Sam Newman. He said on a project we were on, he said, we were busy making everything use, I think it might have been Maven, which is a Java build tool, and is, it's widely considered a form of self-harm. And we were migrating a bunch of Java code to use Maven, and I was like, why are we doing this to ourselves? And he said to me, I would rather everything is consistently wrong than inconsistently anything. And that really landed for me. So, it doesn't matter that we're using a tool that we don't like or that we're not happy with. If everything is now pointing in the same direction, we can now make all of that code be what we want. If it's all over the place, then trying to bring any of it under control is really hard. So whatever the house style is, however you might disagree with it, when you're writing new code or when you're changing existing code, make it look like that code. Don't make it look like code that you think it should look like, right? That's not fair on other people, because now you cause them cognitive load. You cause them to shift how they read code because of your code style versus everyone else's. And this is what I was talking about with the humility, the egoless part of programming with idiomatic style. That doesn't mean nothing ever changes. It means that when you do decide to change, you do that as a team. You say, let's adopt these idioms. Let's change the way we're doing this thing. And then you have a deliberate way to do that. So you might say, okay, all new code will use our new idiomatic style. We'll leave all the old code for now. Every time you go in to change something, also bring it up to date. So the idea is then that over time, only the code that we've touched recently looks like the new stuff. And over time, the old stuff we haven't touched. Then we might make a decision to go and just refresh all of the old code as a separate piece of work sometime. But these are choices. These are team choices and team decisions. And this is the important thing. You can only write idiomatic code if you bother to learn the idioms, right? You can try and enforce a C# imperative style on F# code. It will let you, but you won't, future you won't thank you. Yeah, and no other F# programmers will thank you. Likewise, as you move to, say, .NET Core, there is you'll see that there are different idioms. The .NET Core team has adopted different programming idioms and idiosyncrasies than traditional .NET code. And again, it's about understanding why they made those decisions and then adopting those for yourselves. You can only write idiomatic code if you bother to learn the idioms. So then finally, domain-based. So we look at domain-based code. So what does this mean? It means code in the language of the domain. So this is domain-driven design 101. If you're writing about patients and healthcare and hospital visits, then your code should have patients and healthcare and hospital visits as first-class construct, right? If you're writing about trading systems and futures and options, then your code should have trading systems and futures and options in it. I contributed to a lovely anthology called 97 Things Every Programmer Should Know, and that was my one contribution, was code in the language of the domain. And also to point out there's multiple domains. So again, Eric Evans, who came up with the idea of domain-driven design, he mostly works or has worked in shipping, in logistics systems. And so in that context, for instance, a ship from the finance department is a depreciable asset. It has an insurance value, it has a scrap value, and so on, right? The same ship from a logistics perspective has a manifest, a cargo, an itinerary, and so on. From a crew perspective, from a navigation perspective, it has a crew, it has a heading, it has weather conditions, and each of these things are very different ways of modeling the same concept, which is a ship. And they're necessarily different, and they're necessarily not terribly useful to the other subdomains. So understanding there's multiple domains going on and being aware that when your code is in each of those domains. But also, and this I find a lot more in the wild, is a lack of domain structure. So, and Ruby on Rails, I think, was the biggest contributor to this, not because it's necessarily a bad framework, just because it was so insanely popular. And what Rails did, it was one of the first frameworks to do this, was to give you a complete skeleton project. So you say Rails new, your project, and it would give you all of the directories and a bunch of stub files and whatever else. At last count, I looked at it sometime last year, and it would generate you in excess of 50 directories with like many files, like this insane amount of cruft just to start working on a project. But apparently that's okay. Anyway, at the top level, it has things like models, views, controllers, helpers, a bunch of other things that I don't even know. And so that means that if I look in any Rails code base, I see models, views, controllers. I don't know what it does. I know what it's made of. It's made of Rails because it has models, views, controllers, blah, 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 blah. Instead, when I look in the code base, what I want to see at the top level is the solution space. I want to see the code for the solution. So I can see that there's a payments subsystem, and there's a loan subsystem, and there's a customer onboarding subsystem, rather than the pieces that make it up. Sure, I've still got models using controllers, but again, this goes back to single responsibility principle. My responsibility isn't the view part of this thing, like we used to do in the old siloed world of the 1990s. My responsibility is add a new payment type. And add a new payment type. I'm going to touch models, I'm going to touch views, I'm going to touch controllers. I'm a grown-up, I'm a big boy, I can do these things, I've got my tests, I'm feeling confident. And so I'll have all of that in the payment section. And so I'll still have these framework artifacts, but I have structured them where I want to do the work, rather than having to then do the work spread across multiple different places. And this brings me to the idea of domain boundaries. So we want to use domain boundaries, these subsystems I was talking about, like the shipping versus logistics versus finance versus I can use these as module boundaries. I can use these as deployment boundaries. So I can just deploy the new payment subsystem. I can just deploy an update to loans. I can deploy an update to the customer onboarding, rather than having to push out a whole bunch of all my models go out together. Or worse, have one of these like super fragmented build systems that picks a little bit out of this folder, a little bit out of here, and a little bit. So it's not obvious which things then get deployed together. So especially when I shift to a small components architecture, like a microservices type architecture, or a serverless kind of functional architecture, what I want is to see the units of things that I'm deploying. So there we have it. So this is Cupid. So it's composable, it's Unix philosophy, it's predictable, it's idiomatic, and it's domain-based. So let's take a look very briefly at some applications of Cupid. Just spend a couple of minutes. If I'm looking at a code base, someone said to me on Twitter, they said, I'm using Cupid as a way of assessing some code we're looking at. We've got this legacy system, we know we're going to do a load of work on it. We're finding it a really useful lens. We're looking at which parts of it are, the degree to which, as a checklist, how composable, how idiomatic, how Unix-like various parts of it are. And then we're using that to come up with a plan of which parts of this do we think will benefit from which characteristics, moving towards which of those properties. So, for instance, we've got a particularly cryptic part of the code base that if we make more domain-based, it'll help us make more sense of it. And it'll also help us understand where we can separate it out into subsystems. So the idea for it that it's an assessment tool is fun. Code critique. So I talk about code critique as it's like a code review, but it's for the team to learn, not to critique, not to review a piece of code. So the goal is not looking at Dan's code and saying, hey, Dan, you got that wrong and this is out of whack and you should have done this. It's to maybe look at 2 or 3 places in the code base where we're doing similar things and saying, okay, to get consistent, which of those things are we going to go with? And then we'll change the other ones to fall into line. Or which combination of things are we going to go with? So using Cupid as a basis for that kind of critique discussion and consistency discussion can be powerful. Deciding where to start with scary legacy code. Okay, so I'm looking at a big a big ugly code base, and I want to fix everything, and I can't fix everything, right? So I need to do something about that. And so I'm stuck. Where do I start? Again, I can use Cupid as an overlay on this, and I can say, right, if we were to make this more Unix-like, if we were to try and identify boundaries here, if we were to make this more predictable, let's run this and let's find out where it's not working. Mike Feathers calls them characterization tests, where you write tests for an existing legacy system which capture your assumptions, your understanding of what the code does. And I haven't done this, but a number of people have asked me to do this, so this may well be on the horizon, which is that you could use it as a syllabus for a programming course. We're going to take a bunch of code and we're going to gradually, iteratively apply these properties to it, or introduce these properties into this code, and just do it before and after and see what we think. Or I could imagine Cupid used on something like a code retreat, where we try to build code in multiple different ways. Let's take some code and try and build it in a composable way, in a Unix-like way, in an idiomatic way. And so recently I put out a website called cupid.dev, which is there now. It's a static website built with Hugo. And what I did, I broke out the original article. So I wrote the article of Cupid after a year of giving talks about it. And now I've broken that out. So you can go to cupid.dev. That's if you're going to talk about this or tweet it or share it with your colleagues. This site, I'm going to look after this site, so you can permalink to anywhere in here. Every paragraph in here is a link, is permalinked. So every heading in here is permalinked. So you can go straight to the specific content you want, share it with your colleagues, use it as an assessment tool, and see where you get on. I've also started a groups.io group called Cupid Joyful Code. So come along and join that. It'd be lovely to see you there, or get in touch. I'm on Twitter as Tastapod. I'd love to hear your stories with Cupid. So with that, I say thank you very much.
Thank you, Dan. I found your talk very, very profound. I mean, easily digestible, but very profound at the same time. So yeah, I loved it.
Thank you.
And by the way, once we finish the conference, like in 3 hours, we're having a call with the client to discuss about the code base. And I look at Dan, and I think we're having the same thing in mind. So we're going to use the Cupid lens, in the conversation. That's one practical thing that I got from your talk. Thanks a lot.
Fantastic. Please do, and let me know how you get on as well. I'm very keen. Or I don't want to just be me on Transmit. I want to hear people's case studies and adventures, and where it didn't work, and what they would change, or what they're struggling with. Is absolutely what I'm keen to hear. So yeah, let me know how you get on with your client.
Definitely, we'll do that. Absolutely,
we'll do. And yeah, it was a really fun session for me also, because it takes me back to various points in my work. So even when you said the domain-based language, and of course domains also change in time or throughout the project. But if you were, I don't know, 20 years ago, where I don't know, it didn't really work if you would rename your files in source control in some systems, or then you saw some people reluctant to change the names. So it was legacy names that were used 10 years ago.
Yes, yeah, and yeah, or a name that you've got in the code base, but then no one in the business uses it. So it only exists. It's just some quirky name that someone came up with when they were first writing this thing, and like no one apart from that one guy has any idea what this thing does.
Mm-hmm. The other thing that I got from your session is the way I'm going to look from now on at the single responsibility principle. Definitely. And then I have a question regarding the composability. Does that imply also reusability? I mean, do they have anything in common in your way of thinking of it?
That's a great question. So where are we? Reusability. So yes, I mean, yes, but and this is a lovely quote from Rod Johnson, who wrote the Spring Framework. He says, reuse is overrated. Code for use.
I agree.
You know, you can, and my riff on it is you can make something so simple that it's really easy to reuse, or so complicated that it can do anything. And one of these is much harder. Right?
Yeah.
You know, resisting the temptation to make your thing do more is incredibly hard. One example from unfortunately, most of my examples from the Java world. In the early 2000s, a colleague of mine came up with a Java XML serialization library called Xstream. So Xstream. And Xstream, literally all it does, it takes Java objects and POJOs or structures of POJOs, and it just traverses them and turns it into XML. Now, there were already tools around that did this, but they were just really complicated and really over-engineered, and you ended up with this huge, massive, XML and XSLT and schemas and all this stuff. And he said, literally, all I want is some angle brackets and my data. What he was really doing was inventing JSON, but 20 years before JSON. And so he wrote this library called Xstream, and he tried to host it on one of these early hosting sites, so long before GitHub. I think it's called FreshMeat. And they said he was rejected on the grounds that it was too simple. We're not going to host your project because it's too simple. 20 years later, it's still being used. Xstream is being used on the International Space Station, right? It's one of the very few open source Java libraries that is trusted to run code in space. Because it just does this thing incredibly well. It's really, really hard to come up with an Java object structure that you can't put into Xstream and get some very sensible looking XML out of. And the thing that he resisted again and again and again over the years was adding more stuff. It just does this, and it does it incredibly well. Yes, code will get reused, and again, this is, I think, where we got it wrong, or not where we got it wrong, where Solid made an assumption in the 90s, or rather Solid was working off an assumption in the 90s, which is that we would reuse source code. So one business model was going to be that we would have C++ source codes of domain-specific things. So you'd have like a healthcare code base, or you have and you'd license one of these code bases and then extend it to do your thing. And this is where the open close principle came from, was like, if you're going to give your source code to other people, you need to be really clear which bits they're allowed to muck around with and which bits they're not, because they're going to break stuff. And so that's where open close principle came from. It turns out no one ever did that. People license binaries. Now people license services. So it's all SaaS. But people would license a library. You'd use someone else's code library. So composability at that stage is at an API level. You would compose a logging framework. You'd compose a HTTP library. And so all of these things, and again, this is why NPM absolutely exploded and Node.js absolutely exploded, is you get lots and lots of tiny little single-purpose things, and they get reused and reused and reused, and no one ever goes in and looks at the code unless they're debugging something. They just use the API. They use the fact that this thing emits JSON, or this thing converts text to emojis, or whatever it does. And so you end up with this this explosion of little single-purpose libraries.
Yeah, definitely. Thanks a lot. It looks like you're mastering the word and you're playing the word with the word very, unexpectedly sometimes, but very well. So I love the quote that you had on your tweet from probably last year. It was with the "I'm an architect."
Oh, an architect, yes. Thank you.
Yeah, an architect. Yeah, brilliant. I think we've got time for one final questions, as we also have our next guest in the lobby. But by the way, I'm going to invite Dima with us. Maybe you get the chance and take the opportunity to meet each other. Hi, Dima.
Fantastic. Hi, Dima.
Hi, everyone.
Hi. So while in the lobby, we had this very beautiful conversation. I promised one final question. So we discussed about joyful code. And do you have a preferred industry? I mean, an industry, a domain industry where you'd like, really love to work in? I personally have one, which it relates to anything in the healthcare space, which is a broad thing, but anyway, if I get the chance to, or the option to choose, I choose that.
That's a really interesting question. I've practically never made a career decision. I'm 30 years in. I think I've probably made 2 career decisions in my life. Like joining ThoughtWorks was an accident. It was a happy accident, and I had a number of wonderful, really fun-filled, enjoyable years there. But I never applied to ThoughtWorks. Someone sent them my CV, and then told me after the fact that it sent my CV. And also being there, I worked in a whole bunch of different industries, like insurance, telecoms, healthcare, finance, like banking, investment banking, retail banking. I'm sure there are many. Streaming TV, entertainment, lots and lots of different verticals. And I'm kind of industry agnostic, I think. What I like to work with is I like to work with people like you who are excited about a domain. I want to work with someone who's passionate about solving problems for healthcare because they've got a really personal reason that that's their thing, or they really want to fix finance, but not in a pointless blockchain Web3 hype bubble burning the planet kind of way. Right? Oh, sorry, was that my out loud voice?
Yeah,
right.
Thinking alike. So yeah.
There's a lot of good that a lot of people want to do in the world, and I'm kind of a level of indirection, if you like. I like to help people who want to do something do it better. So for me, like, it's not necessarily the industry so much as the context, the situation. I like to be in a situation where I can really help act as a differentiator. If you do these things, you will do your healthcare thing, or your finance thing, or your whatever it is thing, your entertainment thing, so much better, and you'll have so much more fun doing it.
Daniel, thank you so much. I mean, we love you for these words.
Thanks very much for having me.
It's been a really, really good talk, really good conversation. Feels really exciting at Codecamp. At least that's my feeling. And of course, we're looking forward to, I don't know, maybe having you in Iași or in Cluj or in Bucharest or us in London.
I've not made it out there yet, so I've been to Lithuania a few years ago. Actually, probably quite a lot of years ago now. And in fact, I was in Kiev not so long ago. Teaching a class. And so I've been out and I've been to Tallinn a couple of times. So I've been to kind of Eastern Europe. I haven't made it to Romania. I haven't made it to Bulgaria. So they are parts of Europe that I have yet to visit.
Well, we should find the context.